All right, welcome to College Prep Math 3. My name is Zach Austin. This is going to be a quick introductory lecture for Module 1, Lesson 1 of College Prep Math 3. And this lesson should mostly be a review for most students in this class, but it does contain some skills that are going to be very, very important to us throughout the entire course. So we want to make sure that if we don't remember some of the things that we're going to do in this lesson, that we get them down because they're going to keep coming up over and over again. So before we get into some of the skills, we do need to talk about some of the different vocabulary terms that we're going to use. I've written a couple of statements here that we'll see throughout this course, and they're a little different. The first one here, this 8x squared plus 5x minus 7. This is an example of what's called an expression in math. Okay, and an expression is really just any combination of terms like this that doesn't contain an equal sign. The second statement down here, the 5x minus 3 equals 13. This is an equation, and we can recognize that very easily because it's got that equal sign in the middle of it. It's an expression that's equal to another expression. That's how we form an equation. Okay, so the pieces that make up these statements are called terms. And so in this first statement here, there are 3 separate terms. We can determine where these terms are by looking for pluses and minuses and equal signs. And so down here in the second one, there's 3 terms as well. 5x and 3 are terms on the left side, and the 13 is a separate term on the right side. So those are some of the key vocabulary terms for this lesson, and we will see those again throughout this course. One final one I want to discuss, if we look at this 8x squared term from this first one, this 8 at the beginning of this term has a name as well. It's called a coefficient. And so the number in the front of a term is the coefficient of that term. And if you have a term like x, okay, that doesn't have a written number in front there, the implied coefficient on that term is a 1. And similarly, if you have something like negative x squared, okay, the implied coefficient on that term is a negative 1. And these are going to be important things to understand for some of the things we're going to do in this lesson as well. Okay, so the first big topic in this Module 1, Lesson 1 lesson is about simplifying expressions. And I can tell that this is an expression again because there's no equal sign, right? We're going to have a slightly different process that we use if we have an equal sign instead. But this one, no equal signs, it's an expression. Our answers are typically going to have multiple terms, and we're not going to be able to get a single number solution to this. We're just going to do what we can do and not go too far is kind of one of the keys here. Okay, so to simplify this expression, the first thing that we're going to do is we're going to deal with these parentheses that we see there. If we have parentheses, we're going to distribute our coefficients of those parentheses across. So here we can distribute this -6 across the first one, and for our second parenthesis, we can distribute this 5 to each term in there. So that's going to be our first step. When we distribute, we're going to multiply our coefficient times each of the terms inside those parentheses. So first, -6 times x is -6x. -6 times 5 is -30. Okay, over here, +5 times 2 is +10x. And then +5 times +1 is +5 there as well. Okay, next, what we're going to look for is what we call like terms. And like terms are terms that have exactly the same variable parts. If you have like terms, you can combine them. And if you don't have like terms, then you just have to leave them separately. So in this problem, we have a couple of pairs of like terms, the -6 and the +10, the -6x and the +10x. Those are like terms because the variable parts match. And then -30 and +5, those are like terms as well. In fact, we call those constant terms. Any terms that we have that don't have any variables on them are called constant terms. Okay, and so we can put those together. When we're combining like terms, we just add the coefficients. So -6 plus 10 for this first example will give me 4. and we leave the variable part the same. So was an x before, it's still going to be an x after we add them. Negative 30 plus 5, those are like terms. We can combine those as well. So negative 30 plus 5 is negative 25. And the variable part stays the same. There was no variable part, so it's going to still be a constant after we're done with combining there. Okay, and then at this point, we are done. We cannot go any further. This is just an expression that we're simplifying. Okay, so we can't solve, there's no equal signs. We can't go any further, and our terms are not like. If our terms are not like in an expression like this, we have to leave them separate. So 4x minus 25 is our solution here. Okay, so this problem is different because of the equal sign in here. So we're looking at an equation on this problem, which is a different style of problem from the last one for sure. We're expecting a number solution most of the time. Not always. There are some other things that can happen, but most of the time we're expecting to get a single solution, unlike the expression solution we got when we were just simplifying that expression. Okay, so for this problem, my instructions would tell me to solve, and that's what I'm going to do. I'm going to try to get the x on one side by itself, and we're going to use a couple of properties to help us make that happen. The first thing that I want to do, if I'm trying to get that x by itself, so I want to get rid of all of my terms that don't have any x's on them. In this case, that's that plus 2 there. And so we're going to use this thing called the addition property of equality to get and move that over to the other side. What that says is that we can add or subtract the same number to both sides of our equations, basically like a scale. As long as we do the same thing to both sides, we're keeping it balanced since those two sides are equal. So if I want to get rid of this plus 2, I'm going to subtract 2 because 2 minus 2 is equal to 0. And according to the addition property of equality, if I do it to the left side, I need to make sure I do it to the right side as well. So those 2's, 2 minus 2 is equal to 0. Those we say that those will cancel off. Leave us with that negative 5x by itself. Over on the right side, negative 8 and negative 2, we put those together, we get negative 10. Okay, and so I've gotten rid of all of my terms that don't have any x's in them. My x term is by itself on the left-hand side. Okay, so I want to get rid of that negative 5 left. Again, my goal when I'm solving equations is to get the x on one side by itself. If I'm trying to get rid of that negative 5, notice how that negative 5 and that x are multiplied. Okay, we have this thing called the multiplication property of equality that will let us solve this. If I want to get rid of a multiplication, I'm going to divide by the same non-zero number on both sides, and that'll clear it off. So in this case, I want to get rid of this negative 5. I'm going to divide by negative 5. Again, if I do it to the left side, need to keep my equation balanced, need to make sure I'm doing the same thing to the right side as well. Negative 5 divided by negative 5, those are gone. Leaves me with the x by itself. And then negative 10 divided by negative 5 is positive 2, and that's the solution to our equation. Again, it's not a surprise that I got a number answer. There are some other things that can happen, but this is by far the most common thing that will happen when you're solving an equation. You're going to get a number or numbers that solve that equation. For linear equations like what we're dealing with here, typically we'll just get one solution. Okay, so this is another equation. Again, we can recognize that it's an equation because we have this equal sign in it. And this one's got more going on, though. You'll notice right off the bat that we have some more complicated expressions on both sides. So a little more to do here. The first thing that we want to do before we do anything with the equation, with moving things from one side of the equation to the other, is we want to simplify both of our expressions as much as possible. So not much I can do on the right. Negative 21x plus 9, those terms are not like. They have different variable parts, so I can't do much over there. But on the left, I can start by distributing this negative 7, just like we did in the first problem that we did. So negative 7 times 3 is negative 21. Negative 7 times negative 1 is positive 7. Okay, and then I'll just bring everything else on down. Can still do a little more simplifying on the left side. The 7 and the 2, those are like terms, so we can put those together. Okay, and that's about all that I can do here as far as simplifying my expression. So once I get to this point, now I'm going to start with the algebra, with moving things from one side of the equation to the other. My philosophy on this is, what I want to do is I want to collect all my like terms. I want to get all my x's onto one side. I want to get all my constant terms onto the other side. Because if I do that, I can just divide and then I'm done, typically. So I'm going to start by getting all my x's together. I'll just move this one over. It's a little bit of a special case here. that we're going to see. So negative 21x plus 21x, those are going to cancel. They're going to cancel over here as well. Okay, so the x terms are all gone from the left-hand side, just leaves me with a 9 over there. On the right side, same thing happens. I'm just left with a 9. Okay, so this is a special case that'll come up from time to time when you're solving an equation. All your variables are gone. If all of your variables are gone, the question that you need to ask yourself is, did I get a true or a false statement at this point? So my equation now says 9 equals 9. That's a true statement. Okay, what that is telling me is that anything that I plug in is going to solve that equation. And so I would just conclude that this can be solved by all real numbers. I can put anything I want into the original equation and it would work just fine. So again, got to really pay attention to whether your statement at the end is true or false when you're dealing with a special case like this where all your variables canceled out. If it's true, all real numbers will solve the equation. Okay, so another equation to solve, and just like in the last one, I'm going to start by cleaning it up as much as I can. I want to take this negative 2, distribute it across the parentheses here. So negative 2 times positive 6 is negative 12. Negative 2 times negative 8 is positive 16. Okay, so next I want to start collecting my like terms. I want to get all my x's onto one side. I want to get all my constants onto the other side. So I'm going to start by moving this 12x over. Get rid of that. Just leaves me with a 16. Over here on the right side, my x's cancel out again. So negative 12x plus positive 12x is equal to 0. So this is another one of the special cases, just like we saw in the last one. Okay, and this one, though, is a statement that is always false. 12 or 16 is not equal to 0. So when you get a false statement like this, and what that's going to tell you is that there is no solution to this thing. Okay, so again, when you're solving these equations, your process is the same, but if all your variables cancel out, you're looking at a statement at the end that's either true or false. If you get a true statement, then all real numbers will satisfy the original equation, and if you get a false statement like this, then there are no solutions that will satisfy the original equation. All right, so hopefully that's enough to get you off to a decent start in this first lesson. Again, hopefully for most of you, this is a review. We'll definitely be using these skills throughout the entire rest of the course. So it is important that you're good at this equation solving stuff. If you find you need a little extra review, please don't hesitate to contact me and let me know what I can do to help get you going, because again, this is not going to go anywhere. It's something that will continue throughout the entire course. So looking forward to working with you all this semester. Please let me know what I can do to help.